So today we will discuss some of the problem types and we will analyze its time complexity. So before going into that, what are the various real world problems we have seen earlier?
Searching, sorting, graphs, solving
numerical problems, so mathematical problems. So these are the various problems that we face in our day-to-day life. So if we take searching as an example, if I want to find some element, we go for searching algorithms. So if I want to arrange the data, we go for sorting algorithms. And if for example, if I want to find the factorial of a given number, that is classified under mathematical or numerical problems. So these are the various problems. So these problems can be solved using many approaches like brute force approach, divide and conquer, greedy method. So there are various approaches for solving a particular problem. But not a given problem can be solved using all the approaches. For example, if we take searching and sorting, it can be solved either using brute force approach or divide and conquer. So for solving any problem, we have specific approaches. So any given problem can be solved using one or more approach. So if we take sorting as example, sorting can be solved using both brute force and divide and conquer. So what is brute force approach?
It's a step by step on analyzing all the elements in an array.
So analyzing all the possibilities. So checking for all the possibilities is called as brute force approach. So what is divide and conquer? It will divide a given array and it is not only array, it divides the given input and and solution is calculated for all the subproblems. If let us assume there is a problem, the given problem will be divided into subproblems. It need not be two. It is divided into subproblems. Solution is calculated for all the subproblems. Finally, it is merged together. So that is divide and conquer. So what are the various sorting algorithms that we have come across? Bubble sort, selection sort, quick sort, merge sort. So if you take bubble sort or selection sort as example, it is an example for brute force approach because we scan the entire array before sorting the given array. If we take quick sort or merge sort as example, there the array is divided into two. So in case of quick sort, array is partitioned into two halves. It need not be equal halves. However, it is divided into two halves. Similarly, in merge sort also, array is partitioned into two halves, and the results of two subarrays will be merged together to finally to form the sorted array. So that is divide and conquer. So now let us see selection sort and let us see how it is solved using brute force approach.
So now let's write an algorithm for selection sort. So as we are going to take the elements 0 to n minus 1. For indexing we use n minus 1. The last element will be n minus 1.
Because the size of array is n. Yeah. So last index will be obviously n minus 1 because array index starts from 0.
Here we use two for loops. The first for loop will be, it starts from the 0 index then it ends by the n minus 2. Because the last, it will end before the last elements, first we used to substitute.
In brute force approach, we use two for loops for performing sorting. Why two for loop is required is that, so sorting is performed stage by stage. So to keep track of the stages, we have one outer for loop, and to perform swapping, we have another inner for loop. So any sorting algorithm which is solved using brute force approach will have two for loops.
So now we are going to assign the I value as a maximum. So the I value minimum. So the I value will be in 0 index. So now let's take a problem. So now I value will be the first value of the index, the given array. So it's 89. It will go for taken 89 as a I value and start from this. Next we go for a second for loop. It will take j. J will be known as a I plus 1. So it will take the second value as the first value for j and it will end in n minus 1. It will end as the last element of the array. So we used to compare both the I and j. If the minimum element is already assigned as I, if the minimum element I is less than or greater than j, so the j value will become as a minimum element. It will just change the value. So after all this, if the j value is minimum than I value, so it will swap the both values. So now we are going to take an 89 as the first value. First we will solve the problem. The minimum value is 0, 89. So the second value will be j is equal to 1. It will just check whether the first value is less than or greater than second value. So here first value will be 45. First value means A is equal to J will be 45 and 89. So it will take the 45 as minimum element. So minimum value will be changed to 45. As it follows the same algorithm for all, at end we will use to swap the all numbers, and the ending element will be 17, 29, 34, 45, 68, 89 and 90.
So as Salim has said, so initially we have three variables in total here, I, minimum and j. So initially both the variables I and minimum will point to the same index. So this minimum index alone will change. Of the remaining elements, it looks for the minimum value. So initially we will leave this value in the first index. Of all the remaining elements, which one is the minimum? So look here and tell me. 29 is minimum. So this index will be assigned as minimum. So the value at the minimum index will be swapped with the value in the ith index.
Yes.
It will be swapped. If the value in the minimum index is minimum than the ith index, it will be swapped. So this is performed till the end. So here we have two for loops. Outer for loop continues till n minus 1, and inner for loop also goes till n minus 1. So time complexity will be n minus 1 into n minus 1. Since this is nested for loop, it is product. So totally it is n squared.
Thank you.